Okay, today's 417. This is video number 53. This is the last enrichment video for this week. I'm going to answer the problems I posed yesterday. I said a car is going 60 miles, 1 hour, and we were asked to turn that into feet per second. And then the second question was a jogger question. A guy does a 5-minute mile, and by that we mean 1 mile divided by 5 minutes as a ratio. So I'll do both of those problems, and we wanted again to turn this into feet per second. Okay, so I'll do both of these problems, and then I'll talk a little bit about the difference, how you could figure that out between a meter and a yard, and basically how you could become even more precise if you needed to be. So here we go. We have to do this problem over here, and we know that 1 mile is 5,280 feet, and then that means 2 miles is double that, 3 miles is triple that, so it follows that 60 times 5280, which is our conversion that I gave you yesterday, is going to be the number of feet that I do in 60 miles. But that was for an hour, so 1 hour is 60 seconds times 60 minutes, okay? And you could probably think about simplifying here, cancel the 60s after zeros, but I'll use the calculator anyway, and I come up with an answer that some kids sent me already, which is 88 feet in 1 second. And I'll just elaborate a little more. 88 divided by 3, which would be the conversion from feet to yards, and I come up with around 29 and a third, but it doesn't make a difference here, around 29 yards per second. So that means you cross a football field in less than 4 seconds, right? Because a football field is 100 yards. So zoom, you've done a football field in less than 4 seconds. You should form, before you take your first physics course, a science course, a basic idea of what I'm doing. And now I'm asked to figure out what this jogger's doing. And remember, I'm claiming it's amazing feat because the person's doing it for over a period of 26 miles, 26.2 to be exact. So here we go again. Well, we know that there are 5,280 feet in a mile, so there's my conversion there. And then 5 minutes is an equivalent of seconds is 5 times 60, right? So again, I could zap the zeros and do it that way, but since we're working with calculators here, I divide 5,280, and then I divide that by 300, and I come up with 17.6 feet, 1 second, which just doing it roughly in your head is about 6 yards, 1 second. And if I consider a football field again and divide 100 by 6, just roughly working the numbers, crossing the football field in roughly 17 seconds, okay? And doing that over the course of 26 miles. Just think about that for a second. 6 yards, 1 second gives you an idea of how fast, what terrific athletes these people are. Okay, so let me take a look at the time here. We're doing good, okay? We got everything done we want to do here. And now, let's see what happens when we propose a new problem. And I'll propose it and slow up just for a second and make sure that you understand the problem. We have, from maybe some scientific textbook, we have a satellite that's circling the Earth, okay? And we're told that it's going 500 meters since it's a scientific problem in 1 second. And boy, you're thinking to yourself, man, I don't know really what's going on there. And I'll be able to do a little bit better now when I use the equivalence that I talked about yesterday. I'll talk about the difference. It turns out the difference is around 8%. In math and the topic of error, which is also another really important subject, that's 8%. And that's an unacceptable amount of error. 0.5% is much better. But we're gonna cheat anyway. Talked about cheating quite a few times. And we'll just say it's 500 yards, 1 second. And then maybe we'll go back a little bit and backtrack, okay? And now, when I start doing that problem, I have to figure out how many miles I'm doing in 1 second. So that would be 500 divided by 1760, 1 second. Now, some of the weaker students are going to say, well, where'd you get that? Well, since 3 feet make a yard, 5280 divided by 3 is 1760. That's how I got it. Well worth considering how I did that, all right? So there we go, and I put that on my calculator, and that turns out to be approximately, excuse me, I messed up the number there, 0.284 miles in 1 second. So this is going really fast if you think about it. It's going over a quarter mile in 1 second. That's unthinkable speed. Let's see what happens when we do an hour. We have 0.284 miles. Again, we should always go slow here in 1 second. But nobody asked you that. We said, how fast is it going miles per hour? Well, there's how fast it's going in a minute. And there's the other 60. That's how fast it's going in an hour. And I'll just put that on here and I'll round. I come up with 1,022 just to throw out a number there, since precision doesn't do anything for us here, miles per hour. And I believe that gives us a good idea of the real speed of this object. It's swishing around the Earth at an extremely rapid rate, at least from what we understand. Remember, there's no gravity up in space, so the numbers turn out to be like this. So I'm going to slow up here for a second and make sure that my numbers make sense. And I'm going to go the other way like I did yesterday, and I'm going to turn my numbers 1020. Notice I'm dropping the 2. It doesn't do anything for me. And I want to come back and get close to 500 to make sure that my reasoning's correct, because that's all that matters in a problem like this. So I'm going at this rate of 1,000, approximately 1,000 miles per hour, and then I multiply that to get back to yards. So there we go. So 1,000 times that, and again, one mile is 1,760 yards. 2 miles is double that. 3 miles is triple that. That's my reasoning. And when I do that, I come up with this big number, which I won't bother to worry about. And then I just divide it by seconds. So 60 times 60 is 360. And when I put the numbers in, I came up with 498 approximately. And there we go. That assures us that our reasoning is correct. 1 second. Okay? So let me just make one more comment. How's the time doing here? Yeah, the time's doing great. Since there are 39 inches approximately in a meter, and 36 inches definitely in a yard, we want to calculate their difference. So if I divide 39 by 36, and you're welcome to do it on a calculator, I'm going to get approximately 1.08. So what is that? That's just saying 8%. And if I do it the other way, of course, as you learned in probably in 7th grade you did work like this, I'm going to get the complement of that, which would be around 92%. So I can always make up my errors anytime. So yards are less than meters. We just said that, as you can see. So 500 yards times 0.92 will give me the number of meters, which I could have done from the beginning, an alternate way of doing this problem, but not as intuitive as the way I just did it. And there we go. So 500 yards is about 460 meters, okay? And to go the other way, okay, how many meters is, are the yards that I could have put in here instead of approximating? I would have had 500 times 1.08, math that you learned in 7th grade. And so that would have been about 540 yards per second. Again, more than 5 football fields. But doing the difference here between the two shows that why we can get away with this stuff, because when I do the math and come up with the numbers in the end, they're about the same. The difference isn't enough that, to really bother anybody except an engineer. So there we go. And of course, this is the easiest way to do it. There are other conversions, 1 mile to kilometers, inches, to centimeters and all that, but that involves more complex work, and it's not as intuitive as the problem that I just did. So I'm going to leave this with you to think about, and I hope you have a nice weekend. And on Monday, like I said in my letter to you this morning, that we'll go back. I'll be using conversions for lengths and things of that nature, and when we get ready for our test, because there will be Anglo conversion problems on your test, but not using things like this. I just thought I'd give you a little taste of what you should be able to do. Okay, that will take care of this.